Good day everyone, today we're gonna show you how to simulate a balanced 3-phase Wye-delta system. So here's a figure. So we're going to find the line current IL and the average power delivered to the load. So let's start up with our multi-sim simulator. So here's our working place. Then we're gonna put our elements based on our given figure. First, we're gonna put our voltage source. Having an amplitude of 110 volts. With a phase of 0 degrees. After that, we're gonna put a 2 ohm resistor which is connected in series to our voltage source. So here we're going to find the current flowing through the 2 ohm resistor. Which is also the line current. So let's add the load impedance, having a value of 9 minus J6 ohm. And it's done.
So since we're done with putting all the elements needed like the voltage source, the resistors, and the impedance load, we will then now proceed to the putting of all the values of each element. But before that, we have to arrange it first in order for it to be easier later on when it comes to connecting the wires and run. So there you have it, we're done arranging all the elements needed. We're now going to proceed to the setting of the values. We have 110 volts, 2 ohms resistors, and an impedance load of 9, 6, and 60 since we assume the operating frequency to 60. Same as well with the second impedance load, we have 60, and the third one is the same as well, 9, 6, and 60. And there you have it, the values of each element. So now we're going to connect each elements to each other. So we'll be putting the ground, and then we're going to connect them each in order for the current to flow, or to know if there's a current flowing through the elements.
Then after, we need to put called a wattmeter to read the power of each impedance load. So put each impedance load a wattmeter to see the power generated to this load. So this is how it looks like from the simulation program. Then run it again so we can see the power generated from this impedance load. and since it runs, as you can see guys, the power generated is 1.25 kilowatt per phase. So in average power, we need to add this 3 or multiply the 1.25 kilowatts by 3. So the average power is 3750 watts. That is the average power by the 3 impedance load are the same. So in this particular situation, the current passing that R1 resistor 1, R2 resistor 2, and R3 resistor 3 are actually the same. You just need to put all the passing through the resistors to be put an ammeter to see the current passing through each line. So here it is guys, as we can see, in R3 it is 20.4 amperes in RMS. So the three are actually the same from R1, R2, R3 since the resistors are set in 2 ohms, and this is the impedance load. The power is 1.25 kilowatts, so the average power will be 3750 watts.